Hey guys, welcome to lesson 3, and we are going to be talking about simplifying radical expressions. So really, that's all we've been talking about is just doing different things with them. So first of all, you need to be careful when you add or subtract. You have to have 3 things. First of all, you have to have the same variables and or exponents. Okay, and the next thing you have to have the same index and the same radicand. And so we'll talk about like exactly what that looks like. Oops, if I can spell radicand, you can even read my 8-year-old handwriting. Okay, so what this means is like a like term would be these because they have the same root, they have the same number underneath the root, and it doesn't matter that the 7's on the outside because like we can look at this as 1 cubed root of 5 plus 7 cubed root of 5 is 8 cubed root of 5. And so same thing, I'll do this in another color. Oops. Same thing with this. So these are the same because again, it's like square root, and this is like 1. So 3 square root of 5 minus 1 square root of 5 is 2 square root of 5. So I'm able to add those 2 terms together because they are similar. Okay, so these are definitely not similar because of the number underneath the square root, but I can simplify this. So the first thing I want you to do is simplify that. Okay, so you should have gotten 2 square root of 2 and then plus the square root of 2. So now I have the same index and radicand, and so I can just add these together. And I don't know why I put a 2 there. Please forgive me. So I have, it's like 1 square root of 2. So then I have 3 square root of 2. Okay, so I'm going to do the same thing with both of these. So I'm going to simplify this one and simplify this one and see what happens. So go ahead and try that and see what you get. Okay, so I showed my steps up here. So 27 times 2 is 54, and I can take the cubed root of 27. It's 3, and 8 times 2 is 16. The cubed root of 8 is 2, so that's where I'm getting those. Now they're the same, and so I can add 3 plus 2 is 5 cubed root of 2. So that's the answer. Okay, so there's really nothing different here except we are incorporating the variables. And so again, like with the setup here is like we need, if you have a variable, they have to have the same exponents as well. So what I'm going to do is I'm going to simplify all 4 of these and see what I can combine. So go ahead and do that. Okay, so when I simplified each of them, this is what I came up with. So like this, hopefully you can see that. That's where they match up. And so now I'm looking for commonalities between the two, like what can I combine? So I see that I can combine these two, and I see that I can combine these two. So I have 3x minus 2x is 1x. And notice that the like square root of 5x, that's stuck. Like it stays put, it doesn't go anywhere. And negative 3 plus 5 is plus 2x square root of 2. And so that's my final answer. Okay, so really this one is the same way. It's just a little bit more involved. So go ahead and see if you can do that. Okay, so for this one, I was able to simplify like this first one, but the second one, I wasn't able to simplify because 5 goes into 3, nope. 5 goes into 2, nope. So everything just kind of had to stay put. But notice what happens is that I have the same index and radicand here. So then I can just add 3x squared y squared plus 2x squared y squared is 5x squared y squared, and then times the 5th root of x cubed y squared. So this is my final answer. Okay, so multiplying radicals, that's not that big of a deal. You just have to have the same root or same radicand. Okay, so like for this one, And so what I always like to think about is like numbers on the outside stay on the outside, numbers on the inside stay on the inside. So I have 5 times -2 is -10. Square root, because it has the same radicand, 3 times 7 is 21. So notice how they work there. Okay, and then 3 times 5 is 15. Cubed root of 10 times 4 is 40. And then if you can simplify it, do it. So I see that 40 is hiding a perfect cube of 8. And so that 8 comes out as a 2. The cube root of 8 is 2. So whenever you push a number to the outside, you always multiply those together. So it's 30 cubed root of 5 for your answer. Okay, so what do we do when they have different radicands? So they have the same number underneath the square root or the root, but so the index, but the different radicands. Sorry. So in this case, I would write it in exponential form. So this is the same thing as 5 to the 1/3 power times 5 to the 1/4 power. And so when they have the same base, it's going to be 5 to the, and then I'm going to add these together. So 1/3 plus 1/4. Let's see. So common denominator of 12. So 4/12 plus 3/12 is 7/12. So my answer would be 7/12. And then make sure that you kind of wrap your mind around how you would write that as a radical. So it'd be 5 to the 7th power, and we're going to take the 12th root out. Okay, so same thing with this one. So this is 2 to the 1/5 power. This is 2 to the 1/2 power. So just make sure that you're good with that. And then again, just add them together. So let's see, common denominator is 10. So I have 2 tenths and 5 tenths is 7 tenths. And then also I can write that as in radical form. And remember, it can also be written like this. So like this or like this. You'll see it both ways. Okay, so go ahead and try these two and see if you can do it on your own. Okay, so hopefully that you saw they're like different. So we're gonna have to kind of mess around with them a little bit to get them to where we can do something with them. So the first thing I'm going to do is just write these in exponential form. So 2 to the 1/3 power and then 3 to the 1/2 power. So when you have a case like this, try to get a common exponent. So this is kind of important. Get the common exponent instead of a common base. So let's say that this is, and it doesn't have to be, okay, so let me just be clear. It doesn't have to be everything, but just the root. So common root. So my common root or denominator, right, would be 6. So this is 2 to the 2/6 power and 2 to the 3/6 power. So when I have that that denominator the same, that means that my root is the same. So if I were to rewrite this, I would have 2 squared on the inside and 2 to the 3rd power on the inside. I'm sorry, not 2. Goodness gracious, I'm having issues with this problem, aren't I? This is a 3. And so now I can definitely do things with it. And so I have 4 times 27. And so I have the 6th root of 108. So let's try this one and see what you can do with that. Okay, so these are my steps here. The common denominator was 12, and so that became my root. And then I have 5 squared times 2 cubed, and I ended up, when I multiplied those together, as 200. So my answer is going to be the 12th root of 200. Okay, so now let's go to different different types of problems. So what happens when you have, like, you're multiplying, you're distributing, right, with more than one term. So we're distributing this. So what happens? I'm going to be multiplying it. So just make sure that your root is the same. And so that first term is going to be 5 cubed root of 8, and then plus, and then I'm just multiplying 7 times this. So I can just say 7 cubed root of 2. So what's sticking out at me is I can simplify that. The cubed root of 8 is 2. So 5 times 2 plus 7 cubed root of 2. 5 times 2 is 10. And so this is as far as I can take that one. This one, so it's going to be like just as you would apply any other set of 2 binomials. So I'll start with these. I like to do the FOIL method. It helps me to kind of keep things organized, but you just do whatever you need to do. So square root of x times the square root of x, that just comes out as x. So I have 25x, and then, and maybe I should simplify that out more. Okay, so I have 25, and then when I multiply this times this, it's going to be the square root of x squared. So now you can see a little bit better that that comes out as an x. Okay, let's do this one next. So notice that I still have square root. I can multiply the outside. So 5 times -2, that's -10. But on the inside, I'm going to have xy. On, let's do this one right here. That's the same thing. It's going to be positive 10xy. And then the last one, so I'm doing these two here, is a -4 root of y squared. So I want to point out something. Notice that these are conjugates. So as yucky as they may seem, they are the same problem, except one is positive and one is negative. So we've talked about conjugates so many times before, and when you have conjugates, these middle terms right here will always cancel out. Also, this is the same thing as x, and this is the same thing as y. So my final answer is 25x minus 4y. Okay, so these are not conjugates. So we're going to do the same thing that we did up here. It's just the middle terms are not going to cancel out. And then this one is the same thing as saying 2 squared root of x plus 3. So don't just like distribute this 2. Don't do that. You're going to like write it out like that and multiply them together. So go ahead and do those 2 problems, see what you get. Okay, so these are our 2 answers, and so hopefully you can follow this okay. This is like the first, this one, and then outer is this one, inner is this one, and then last is this one. Okay, and so the last one, finally, we're trying to find the area and the perimeter. So for the area, length times width, we are just going to multiply these together. And so I get 15x to the, remember we're adding these together. So 2/3 plus 1/2, let's see, that is going to be 6 as a common denominator. So 4, 6 plus 3, 6. So 15x to the 7/6 power. So that's my area. And then the perimeter, remember, you just add everything around. So I have 5x to the 2/3 plus 5x to the 2/3 plus 3x to the 1/2 plus 3x to the 1/2. And so I really can't do anything with any of these. They're just like terms. So I have 10x to the 2/3 plus, and then again, keep these the same, 6x to the 1/2. And this is be my perimeter, and this is going to be my area. And that's it.